Hello, my name is Berkay Karaağaç.
Hello, my name is Saifullah Umayyad.
Hello, my name is Maxim Kiselyov, and today we will be presenting a car brake disc manufacturing.
Okay.
Introduction to brake disc manufacturing. The brake disc, also known as the brake rotor, is a vital safety component in modern automobiles. Its primary function is to convert kinetic energy into thermal energy through friction, allowing the vehicle to slow down or come to a complete stop. With increasing demands for performance, durability, and sustainability, the design and manufacturing of brake discs have evolved into a complex engineering challenge that blends materials, science, precision, machining, and advanced quality control. This presentation explores the full life cycle of a car's brake disc, from raw materials to final assembly. We will examine the key materials used, such as cast iron and carbon composites, delve into the technical process like casting, machining, and surface treatments, and highlight modern innovations that improve performance and reduce environmental impact. Understanding the manufacturing process not only reveals the engineering behind safe braking, but also showcases how automotive manufacturing continues to advance in efficiency and technology. Join us as we uncover the engineering marvel behind every safe stop, the brake disc.
Okay.
Technical drawing of a brake disc. The disc brakes are made from disc, caliper, hub, piston, brake pads, and rotor. A typical brake discs have pad wear sensor, brake pod shim, disc brake hardware, hub and bearing assembly, disc brake rotor, hydraulic brake house, bleeder screw, and a caliper assembly. Why technical drawings matter? Uh, Technical drawings ensure dimensional accuracy during manufacturing, allow precise machining and tolerances, serve as documentation for quality control and replacement parts, facilitate communication between design, engineering, and production teams. Pattern and mold preparation. What is a pattern? A pattern is a replica of the brake disc used in form the cavity in the mold. It accounts for shrinkage and machining allowances and plays a critical role in the casting process. Pattern materials. Main pattern materials for pattern and mold preparation is wood for prototypes and low volume procedure and production, plastic or resin for higher precision, and metal for high volume and reusable patterns. What is a mold? A mold is the negative cavity formed using the pattern. It holds molten metal during casting and shapes the final brake disc. Mold types. There is green sand molds, most common for cast iron brake discs, using a mixture of sand, clay, and water. Shell molds for better surface finishing and precision, and core inserts used to create internal ventilation channels in vented discs. Key consideration: dimensional accuracy. Pattern must include machining allowance. Surface finish. Mold quality directly affects disc surface. Draft angles helps remove the pattern from the mold easily. And cooling channels. Mold design influences heat dissipation and solidification time. Why does it matter? The pattern and mold stage is critical to achieving consistent part geometry, reducing defects like porosity or warping, and ensuring cost-effective mass production.
Okay.
Casting the brake disc. Casting overview. Casting is the process where molten metal is poured into the prepared mold cavity, shaped by the pattern, and allowed to solidify in the form of the brake disc. Metals used in casting. Gray cast iron, most common material due to excellent thermal conductivity and wear resistance, and carbon ceramic alloys, used in high performance and racing applications of a car. Casting process steps. The first process step is melting. Cast iron is melted in a furnace at 1200 to 1400 degrees Celsius. Pouring. Molten metal is poured into the sand mold under controlled conditions. Solidification. The metal cools and hardens into the brake disc shape. Shakeout. The mold is broken and the raw casting is removed. Cleaning. Removal of sand, scale, and excess metals like risers and sprues. Key considerations. Pouring temperature affects flowability and filling of mold. Ventilation. Proper air escape is needed to avoid casting defects. Cooling rate influences grain structure and final strength. Defect control minimizes porosity, cracks, and inclusions. Why casting is crucial. The casting step determines the brake disc's base geometry, material integrity, and over quality, making it foundational for later machining and performance.
So about the fettling. Fettling is the process of cleaning up the disc after it is made from a mold. It is there to take off extra stuff like sand, dirt, or like sharp edges. This process makes a disc look and work better without damaging the surface to an excessive degree. For brake discs, this guarantees safety, smooth performance, and proper fitment. The tools are shot blasters, angle grinders, wire brushes, and CNC machines. So the process, fettling processes for brake disc. So there are like 4 of them: shakeout, surface cleaning, deburring and grinding, and inspection. For shakeout, casting is removed from the molds, and then sand and cores are separated mechanically or manually. Surface cleaning, rust, sand, and scale removed using shot blasting or grinding. As you can see the top picture, it's shot blasting. Deburring and grinding. In deburring and grinding, sharp edges and burrs smoothed out, surface leveled for even brake pad contact. For inspection, I mean, it's obvious, it's checking the inaccuracies, what's checking for some problems. About machining. So what is machining? Machining is the cutting and shaping of the brake disc, so that is the correct size and shape. It smooths the disc out and gets it ready to play in a car. Techniques such as drilling, milling, and turning require skilled operators who can read blueprints, take accurate measurements, and run manual or CNC machines. So, can you go to the next slide, Saif, please?
Yes.
Thank you. So, why it is necessary? First of all, it makes sure the disc is the right size, and it ensures precision and smooth operation. It removes surface defects from casting. It prepares disc surface for optimal braking performance, helps the brake pads touch the disc evenly. Even a slight wobble could lead to poor braking performance, vibrations, or even dangerous failures.
Okay.
If the disc is not shaped right, it can shake or not stop car well. About the tight tolerances, so it's important. A brake disc must maintain a consistent and even surface to ensure smooth contact with brake pads. Brake disc must be very precise. They need to be even and smooth. The deviation between the disc and the movement should not exceed 0.05 millimeter. In a fast or race car, the brakes will work bad even if a small problem develops. Typically, if tightly machined disc reduces rotor-induced vibrations and brake noise, contributing to a smoother driving experience and better ride quality. In racing or high-performance vehicles, even microscopic inconsistencies can impact handling and braking response or high speeds, making precision even more essential.
Okay.
So machining processes used. So there are 4 again: turning, drilling, grinding, and facing. About turning, it removes material from the outer and inner surfaces of disc. The brake disc is rotated while a cutting tool removes material to achieve the desired diameter and thickness. As you can see in the top picture is the turning machine. So drilling creates holes in the disc surface, as you can understand. Precision holes are drilled to reduce weight, improve cooling, and help with gas and water dispersion. So the
Okay.
other picture is drilling machine. About grinding, it produces a smooth surface finish and ensure accurate thicknesses. Abrasive wheels are used to finish both sides of the disc simultaneously. Top picture is again the grinding machine, and the bottom picture is facing machine. Facing machine is ensure both disc faces are perfectly flat and parallel. Both sides of the disc are machined to eliminate warping, or unevenness.
Okay.
So about CNC machine. CNC is the abbreviation for computer numerical control. It is a machine that cuts and shapes parts with a computer. In brake disc, it helps make them ultra precise. It involves the use of computer controlled machines that follow pre-programmed instructions, like G code, to perform precision machining operations. Can you go to next slide, please?
Okay.
Thank you. So CNC machines used in a brake disc manufacturing. CNC lathes, CNC milling and drilling centers, and CNC grinding machines. For CNC lathes, used for turning operations to shape the outer and inner surfaces of the disc. So the first one, the bottom picture, is the CNC lathe. CNC milling, drilling, and centers is used to create vent holes or slots in a performance disc. CNC grinding machine is used in final stage to achieve the required surface finish and tolerances.
Okay.
So balancing. Why balance matters? If the disc is too heavy on one side, the entire car can become a bit of juddering handful when you must brake and slow the thing down. This can be dangerous. Balancing ensures the disc rotates evenly. So there are 2 types of balancing brake disc: static and dynamic balancing.
Okay.
Static balancing. This is done by placing the brake disc on a balancing machine that detects any heavy spots. If a section of the disc is heavier than the others, material is removed from that area to balance the disc. This is typically done at low speed and is mainly used for components that don't rotate at high RPM.
Okay.
Dynamic balancing. For components that rotate at high speed, like brake disc, dynamic balancing is used. This process checks for imbalances while the component is spinning, simulating the real-world conditions it will face. The disc is adjusted to ensure a consistent and smooth rotation. Necessary. Vibration reduction. If a brake disc is imbalanced, it can cause vibrations during braking. This leads to brake judder, where you feel the vehicle shaking or vibrating when applying the brakes. Vibration can affect the comfort of the drive, cause uneven wear on the brake pads, and even damage the suspension components over time.
Okay.
Improve performance and safety. An unbalanced brake disc can cause uneven contact with the brake pads, leading to inconsistent braking performance and longer stopping distances. It can also result in warping over time, further compromising safety.
Okay.
Increase the lifespan of brake components. When brake discs are properly balanced, they wear evenly, which helps prolong both the disc and the brake pads. Imbalances can cause excessive wear on specific areas, leading to a premature failure.
Okay.
So balancing techniques, there are three types of balancing techniques: CNC machining, balancing machines, and dynamic testing. CNC machines can be programmed to perform precision balancing during the turning and finishing operations. Balancing machines are after machining. Discs are placed on balancing machines where the sensor identify imbalances and the required adjustments are made. About dynamic testing, in performance applications, dynamic balancing can be done to simulate high-speed rotation, ensuring smooth braking at all speeds.
So everyone, my part is about surface treatment. So, following the dynamic balancing, all required holes and threads are machined into the brake disc. The brake disc then is inspected by using a high precision microscopic laser scanner to evaluate surface flatness. Any irregularities detected are corrected through the CNC machine, which precisely trims the surface to achieve uniformity across the disc face. To finalize the process, the disc undergoes a thermal curing cycle in an industrial oven, ensuring material stability and surface integrity. This was the summary of a surface treatment. Okay, now let's go into deeper information for the surface treatment. Advanced surface treatments and finishing techniques for brake disc. So we have a shot peening plus plasma nitriding. Combined treatment improves wear resistance and fatigue strength via surface hardening and compressive residual stress. We add a thin layer of zinc coating phosphate or a geomit coating to prevent rust formation, especially important for non-contact areas. Thermal stress relief. The cryogenic treatment involves deep cooling to stabilize the metal structure and reduce internal stresses, enhancing crack resistance. And then the surface grinding to double disc grinding achieves a finer surface finish, better parallelism than CNC alone. Advanced surface treatments and finishing techniques for brake discs. We have the nitriding, shot peening, and we have also the argon post treatment. Okay, so we have those three treatments. We are going to compare them now, whether they can be done before the CNC or after the CNC or post machining. So the shot peening is done after the CNC, plasma nitriding done after the CNC, with the laser cladding after the CNC. But the shot peening usually is not done post machining. Plasma nitriding only if necessary, unlike the laser cladding often required. Brake disc quality control process. After we have done the coating, the balancing, and the surface treatment with thin layer. So after we are done with the surface treatment, the balancing, and we have may put in the discs in the oven to cure with thin layers of coating, we are going to use the quality control process. So the quality control, a critical phase that ensures the product meets all safety and performance standards. The process begins with through visual inspection to identify any surface defects such as cracks, porosity, or inclusions. Next, precise dimensional checks are carried out by using tools like calipers, micrometers, or coordinate measuring machines, the CMM, to verify thickness, runout, and other critical parameters. When necessary, non-destructive testing NDT methods such as X-ray or ultrasonic scanning are used to detect internal flaws that aren't visible on the surface. For selected samples or high-performance disks, dynamometers testing is performed to simulate real-life braking conditions, evaluating how the disk behaves under heat and mechanical stress. This helps ensure optimal safety and reliability in actual driving environments. So the picture on the right is a picture of a dynamometer with a brake disc being tested, and the same brake disc was put in a few weeks later in one of the Formula 1 cars, and the car that race didn't have any brake failures, unlike many other cars. Once all tests are successfully passed, the disc receives final protection coating, commonly to be zinc, nitride, or similar materials, to boost corrosion resistance and durability after coating the disc. So the picture we have, so the base is the brake disc, and the machine itself pours out a laser beam with a melt pool to coat. After it is the connection zone and heat influence zone. While the laser beam is moving, someone is literally melting the pool to coat the brake disc. Brake disc quality control process. Last but not least, the disc is labeled for traceability, carefully packed and shipped to the distributor or vehicle manufacturer, ready for installation. These are our resources, and now we are going to show you a video that talks about the manufacturing process of